We call the logarithm to the base 10, so log base 10, the common logarithm. And in fact, where you see log given without a base, the intended base is base 10. This is what the log button on your calculator will do as well. So if you're asked to find the log of 426, what you're being asked to do is evaluate the logarithm of 426 to the base 10. Now, without using a calculator, we can still estimate an answer. We know that 10 to the power of 1 is 10. 10 to the power of 2 is 100, so we're getting closer to 426. And 10 to the power of 3 is 1,000. So now we've overshot. So we know that the logarithm of 426 to the base 10 will yield an answer between 2 and 3. So in other words, 426 can be obtained by evaluating 10 to somewhere between the value of 2 and 3. Hitting the log button on your calculator, followed by 426, we get 2.692. In other words, 10 to the power of 2.692 will yield approximately 426. How about a small number? Let's find the logarithm of 0.0365. Although we can certainly just reach for our calculators, let's estimate the answer. 10 to the power of -1 gives us 0.1. So that's larger than 0.0365. 10 to the power of -2, on the other hand, gives us 0.01, which is a value smaller than 0.0365. So I'm expecting an answer to be between -1 and -2. So the logarithm of 0.0365 to the base 10, if I punch that into my calculator, I find is -1.438. Once again, this means 10 raised to the power of -1.4 is approximately 0.0365. The anti-logarithm isn't anything terribly exciting. It's simply the inverse of the logarithm. And in fact, in the previous example, where we found the logarithm to the base 10 of 426, and we found that that was equal to approximately 2.692. When we read out the conclusion by saying that 10 to the power of 2.692 is equal to 426, or 10 to the power of 2.692 is equal to 426, that's an example of using the anti-logarithm. The anti-logarithm, or the inverse of the logarithm, is simply the base to the power of x. So for the logarithm of base 10, the anti-logarithm is 10 to the power of x. This isn't something that's new. We've been doing this all along. It just more formally lets us talk about how to solve for the logarithm of y, given that the answer is 1.185. Remember that if the base isn't given, the base is 10. So this merely says 10 to the power of 1.185 is equal to y. So to solve for y, we need to evaluate 10 to the power of 1.185. You'll find that above the log button on your calculator, you have the anti-logarithm, 10 to the power of x. So to punch in 10 to the power of 1.185, we access 10 to the power of x, and then type in 1.185. This leaves us with a value for y of 15.31. You have one more logarithm button on your calculator. It's written as ln and pronounced lon. It looks like an in. This is the logarithm to a different base, the logarithm to the base e. What's e? Briefly, e is an irrational number and it approximates 2.718. If you're comfortable using pi, which is approximately 3.14, you can think of e in the same way. E is just a number. If we want to represent it exactly, we'll write the lowercase letter e, and if we're okay with the approximation, we can use 2.718. Ln, or ln, we say is the natural logarithm, log to the base e. So recall that the inverse for the logarithm of base 10 was 10 to the power of x. The anti-ln, or the anti-logarithm for log to the base e, is e to the power of x. Once again, you'll find a ln button on your calculator, and directly above it, you'll see is written e to the power of x. Some of you may even have an e button on your calculator, which is essentially e to the power of 1. So if we're asked to calculate the ln of 236.5, we simply punch in ln 236.5, and your calculator will tell you that the answer is 5.466. This simply means that e to the power of 5.466, remember that e is just a number, so we can raise it to a power, will yield approximately 236.5. For this last question, where we're asked to solve for y, where ln of y is equal to negative 0.873, it may help you to write ln y as the logarithm of y to the base e. So the logarithm of y to the base e is negative 0.873, and now you can unwind this. We see that e raised to the power of negative 0.873 is equal to y. So y is equal to e to the power of negative 0.873. Using the e to the x button on your calculator, we find that y is equal to 0.418.